Hello everybody, this is a short video on links and guides. Most technical objects are made up of several parts that are linked or attached together. Like in this table, the table legs are linked to the table top. Let's see what happens next. So you have different types of characteristics that we looked at. The first one is called the direct versus indirect link. So if you take a look at this particular type of table, the legs just directly attach to the top, and there's nothing else attaching them together. It really just fits in. On the contrary, here an indirect link indicates that you need an actual hinge, so a third piece to attach the door to the wall or the frame that's surrounding the table, the door. So you see the difference? We need a third piece, and this is why it's called an indirect link. On the left side here, it is direct because there is no third piece. It is actually made so that it fits directly into the top. Let's see the next type, complete versus partial. So as soon as on the left side here, this is an example of a complete link. As soon as I insert the legs into the top, there's no more movement allowed. So you have to think, when it is inserted, is there a movement? If not, then it is complete link, that this will not move. This is part of the function of a table. The legs are not meant to move. On the contrary, here, the parts are meant to move. This is why we have hinges on the door. And the parts can move independently, meaning that the door will move, but obviously the frame will not. It can move by itself without touching the frame, without moving the frame. And this is why it's a partial link. So there's a bit of liberty in the movement. Let's look at the next one, removable versus non-removable or permanent. We also call it permanent. So this door, you have to think about, if I take apart the hinges like you see here, will it cause damage to the door? So let's watch it again, take it apart. The door is separated, there's no damage, neither to the frame or the door. As opposed to this chair that is non-removable, they can be separated, they can be damaged if they are separated. Why? Because some chairs are actually molded. So like it says here, metal pieces are molded or melted together by welding, for example. So if you take the legs apart, you'll be damaging the chair. So you have to ask yourself a question. If I remove this piece, will it be damaged? So if your answer is yes, that means it is non-removable or a permanent link. And the last one that we looked at was the rigid link. Rigid versus flexible or elastic. So a rigid link will not allow any flexibility, as you see here. It is stuck in its place and it will not budge. As opposed to this example, the elastic link, there is the piece here. Think of some sort of a spring that allows a bit of movement, like such. And at the same time, you have to pay attention that it does go back to its original shape. So this spring, once the guy pushes on the table, it goes back to normal. And this is what we call the elastic or flexible link, that the piece that's attached will go back to its original shape. So you can think of, let's say, Velcro or elastic, or like in this case, a spring of some sort. So we take a minute to just look back at all of them. Direct, indirect, complete and partial, removable and non-removable or permanent, rigid and elastic or flexible. Let's do this little activity together. Drag the 4 correct link characteristics into the box. So take a look. Is the piece inserted directly or is it indirect? Am I able to attach it by itself or do I need a third piece? So let's go with direct. Okay, next question is it removable or non-removable? Meaning, is it removable or permanent? So am I able to remove it without damage, or will there be a damage? So there'll be no damage because it is direct and there is no item such as glue that may damage if you remove the piece. So removable. Next, once the legs are installed, is the link partial or complete? In other words, once it's inserted, will it move or will it stay put? Let's see, complete. And we're missing one more, rigid or flexible or elastic. So again, once we place the pieces, is there a third piece that allows elasticity? Or is it staying in place? I think you know the answer, rigid. And there you go. Let's take a minute and review guides. So in this case, on the left side, the guides allow components to move within a certain way, in this case, in translational, straight motion. So a back and forth motion from right to left. And it can be something that goes up and down as well, as long as it's straight. On the right side, we have a rotational guide where the components are able to move in a rotational way. And without this middle piece, we would not be able to move it in a rotational way. There is a third one called helical, which allows us to move in spiral shape. So advancing and turning at the same time, a bit like the cap on a bottle. It will spin and go up at the same time. That's it for me today. Have a nice evening.